Awesome. Great job, Rob. I mean, explaining some of the core fundamental microservices aspects, patterns, communication. I know we'll go into some of the data in the next segment. So what I want to do in this segment is to kind of talk about some of the deployment aspects of the microservices which Rob talked about earlier. So we're going to primarily look at Kubernetes as our orchestrator platform. So what I'm going to do is I'm going to basically walk you through some of the core concepts of Kubernetes, agnostic of where it's running, show you a few demos. So, my session is going to be kind of more demo focused. So show you some demos with pods, with services, with deployments, then talk a little bit about the microservices application we have and showcase, how we have kind of orchestrated that application which Rob so eloquently showed earlier on the platform. And then later on, I'm going to basically talk a little bit about service mesh. We talk about some of the advanced concepts with respect to the cross-cutting concerns Rob was talking about. If you remember the slide he had about the API gateway, I think there were some questions in terms of, how do you authenticate to the API gateway? How do claims kind of get processed and stuff like that? So we want to kind of look at all those cross-cutting concerns from the standpoint of a service mesh, like a Linkerd, like an Istio, and I'm going to use AKS as a platform here to kind of demo some of these areas. With that, let's get started here. So I think Rob, in the morning, kind of talked a little bit about cloud native, right? He kind of went in detail in terms of what does it mean to build a microservice, what does a microservice design look like, an architecture look like. So I'm going to basically, piggyback on some of the discussion we had earlier and kind of start this discussion with the cloud native paradigm, right? So we hit a lot about cloud native. And if you think about cloud native, it basically stands on these two pillars of containers and microservices. And then if you notice in the picture, we have backing services, and these backing services, if you happen to build obviously in Azure, you're talking about things like Azure SQL, Azure Storage, Azure Service Bus, Azure Redis Cache, and some of the services which Rob showed earlier like Cosmos. And then obviously tons of automation, right? Tons of automation in terms of provisioning the infrastructure, right? Whether it's treating infrastructure as code, and then even beyond that, right? In terms of kind of deploying your application through an automated CI/CD pipeline. So that's kind of the the basic premise, right, of cloud native. So now as we kind of talk about cloud native, and we understand that there's microservices and there's containers involved. Rob talked about microservices in the morning session and some of the afternoon session. I want to kind of touch base on containers and then kind of extend that into the Kubernetes platform. So for those of you who may not be versed with containers, I'm sure most of the folks in this training or the conference are probably aware of containers, but just kind of a rehash for those who you guys, and probably for those who haven't played with this before. So you can think of containers as a portable unit of deployment, right? So think of your applications you're building, whether they are C#, .NET based, whether they are Java applications, whether they are Node applications. So you take those applications, right, and you package those applications along with those dependencies into this one immutable artifact we call as a container image. And now, once you have the container image available, you can consistently apply this container image across different environments, right? And in third or fourth slide here, I talked a little bit about some of the, value proposition with containers and some of the problems they solve. But, as the definition talks about packing this as a single unit, you obviously now have streamlined your deployment, right? So you are no longer dependent on some of the environmental, differences which, can exist between environment to an environment, right? The other aspect of a container is the concept of OS virtualization. So we have obviously used hardware virtualization for a long period of time, and that's VMs, right? And VMs obviously are a great benchmark for isolation. We obviously, use them, almost daily. So that's hardware virtualization, right? So you have obviously host machine, have CPUs, you have RAM, so you slice and dice those resources between your VMs. Now with obviously containers, and especially with Docker, which is the next slide, we have basically taken that to the next level where now we are saying, hey, in addition to obviously virtualizing, using hardware, let's also virtualize OS, which means these containers, they run in their own, host, user host mode, for example, along with other containers, and they happen to share core sources or resources with the operating system kernel, right? That gives us obviously amazing, performance, helps us obviously, boot these containers in a very rapid period of time, and also helps us make these containers kind of dispensable, right? So these containers can come and go, and that's what we'll see later on with pods, right? Where the infrastructure in the Kubernetes environment is treated as, immutable. So you don't basically go and update a running pod. You basically take a new manifest, deploy it, create a new pod, and then the other pod obviously gets terminated, et cetera, and depends on how you have set up your kind of deployment strategy with respect to rolling upgrades, et cetera. So typically, and I think this question came up, I guess, in the morning in terms of, I think there was a question about, hey, do microservices and containers, they kind of go hand in hand? And I think Rob answered it pretty well. I mean, if you're building now hundreds of these microservices, they obviously are for most part decoupled. The best place to run these microservices are these containers, right? Because they're portable. You can go from environment to environment. You can go from on-prem to the cloud, and back and forth. So in terms of how you deploy these services onto these containers, the better practice is to basically take a service and deploy it on this container as a standalone service, right? So you don't typically take two different services which serve different business functions, as Rob was mentioning earlier with his modeling services, right? I mean, there's a service which should serve up a business function. So these different business functions go into these different services, and these services are then deployed as separate containers. So typically a pod would have a container, but as we'll see, in a bit here, there are obviously good patterns because pods lets you do that, like a sidecar pattern where you can deploy kind of a sidecar container along with your application container, kind of as a as an application proxy, like an Envoy, which we'll see with the service mesh design, or any complementary service you may have, like a logging service which transforms particular data for that parent service. So that you can do things like that within a pod. But as far as these services are concerned, which are obviously serving different business functions, they tend to go as different containers. Let's move on to Docker. Again, this is some of the introduction. Docker obviously very popular. The company, same name for the technology stack as well. They have made containers ubiquitous, across the industry. I mean, a few years back, it was, hey, should I use Docker containers, etc. Now, obviously, it's de facto, and now we're talking about obviously orchestration, and even on orchestration front, we are like, hey, we're going to use Kubernetes, and now we're talking more about how do you integrate, say, Dapper, open, OAM, service meshes on top of Kubernetes as these custom resource definitions or abstractions. So Docker obviously very popular out there. I'm sure most of you guys are already kind of using it. In terms of problems these containers solve, right? So I mentioned a little bit about this mutable image, right? So that mutable image basically guarantees us consistency across these different environments, right? Because it's the same image, and now you can apply whatever you basically want to run it, and you obviously have to solve for the configuration aspects of it, for the sensitive data aspects, and I'll talk a little bit about that later. I think on the chat I saw folks talking about key vaults. I mean, that's a great place to store sensitive data. Kubernetes has a good story for secrets, which are not encrypted out of the box. You could on AKS, with some plugins, but mostly base 64 encoded. But you could use K8 secrets, you could use key vault. Now, if you're running stuff inside of Azure, for example, I mean, we have a very great story with managed identity, where now you don't even have to worry about, baking in credentials inside of your container image or passing it through environment variables, for example. If two services happen to be within Azure, you can set those services using managed identity, and then they know, how to talk to each other, and, you basically are good to go there. So that's guaranteed consistency, right, which is great. Productivity obviously improves as well because you spend less time, debugging environments, and so on and so forth. A smaller footprint than VMs. Isolation, we talked about that. In terms of like a default configuration, a standalone container is process and namespace isolated from other containers, which is good. But if there are situations or scenarios where you have like hostile multi-tenant use case, for example, on Windows containers, we do offer something called as Hyper-V containers. So these standalone containers now are wrapped with this worker process, like a lightweight VM, which gives you obviously like a security boundary. If you're using Linux, then there are obviously SECOM, gvisor. There are a few tools out there which you can kind of use to achieve further isolation with respect to security. These containers are performant, quickly start up. That helps obviously us to kind of be able to do this mutable infrastructure, right? Where we can bring up these pods, we can take them down, so on and so forth. So that's all good. Let's talk a little bit about fast forward to container management. So it's obviously all right to and easy to basically open Visual Studio, run a container locally using, let's say, Docker Desktop, for example, on Windows or on Mac. But when you think about enterprise, container management, you obviously have to solve for certain challenges, and then these challenges kind of align with some of the microservices challenges which Rob was talking about, right? So service discovery, now we don't have one monolithic app anymore. We have a bunch of these apps, right, running as these different services. So how do they effectively and consistently discover each other, right? Over obviously these interfaces which we have developed, or REST endpoints, or gRPC, HTTP2 endpoints, what have you. How do we manage state, right? How do we make sure that these containers obviously can be upgraded, with if they are stateless apps, zero downtime as much possible. How do we accurately, report health, the usage, because they're distributed, right, or inside of your cluster. How do we appropriately, place these, containers or pods? And I have another slide coming up which kind of talks about some of the core characteristics of an orchestrator, which kind of then builds up into a Kubernetes specific slide. But they solve for very challenges I'm basically talking about here. And one of the things which customers talk a lot about is the scaling requirements. I mean, if you ask what are the top three things customers kind of ask for when they are looking at their modernization journey, right, and especially going into a cloud native environment, I think one of the requirements is, hey, I want to effectively scale in my workloads. I don't want to scale up anymore. I don't want to be on-prem and scale up. I want to be in the cloud. I want to use this infinitesimal capacity of cloud. I want to scale out. I want to scale back in, and I want to do that in sophisticated, automated way as much possible based on metrics, etc., etc. So that's another thing, that applies obviously within this, within this design. How do you make sure containers do that, right? And obviously you have resiliency to hardware and software faults. So those are some of the challenges, right? So as our containerized workloads grow, right? So we're not managing one-off container or 10 containers or what have you. We're managing a lot more than that. Management becomes complicated, of course, and becomes a lot more complicated as you have more and more workloads which are looking to get modernized, etc., etc. So what do? So we basically want to then move forward and invest in an orchestrator, right? And before we kind of pick an orchestrator of choice, we want to understand what are the things orchestrators should solve for, or what are the kind of top 10 things or 8 things the orchestrator should solve for, right? Let's look at some of those. And these obviously align, again, very closely to some of the microservices challenges Rob was mentioning, right? And obviously some of the container management we talked about, because they kind of go hand in hand. So how do we provision, right? How do we provision or schedule these containers in an automated fashion? Right, that would be one of the characteristics, right, of that orchestrator which you're looking to build or looking to use. Affinity, anti-affinity. How do we make sure that we are placing these containers appropriately, whether it's in terms of placement on a particular node, whether it's kind of a Windows workload versus a Linux workload, or generally if you have a control plane set up for Kubernetes on-prem, as a node, you don't want your applications to be deployed on the control plane. So that would be an NT-affinity. And then you obviously can extend that on the platform like Kubernetes with things like taints and toleration, whether a pod can be deployed on a certain node based on, how taints and toleration configurations are stood up on that. Health monitoring would be the other thing. How do we effectively detect failures with these pods, with these services, with these different abstractions available, and quickly fix them? Scaling, how do we effectively scale out, which would be scaling out the pods themselves. For example, in Kubernetes, we would invest in something like a horizontal pod autoscaler, HPA, which is basically, I'll show that later on, the general architecture of Kubernetes, which is basically a control loop, controller manager, component where it runs, and it basically is looking for metrics to drive that scale out operation. So that would be scaling out these pods, which an orchestrator should do. And then if you set up with a fixed size for your cluster, how do you kind of now also scale out beyond the size of the initial size of the cluster? So if you have a 3-node cluster, how do you make it 4-node, 5-node? So again, make it in a more automated fashion. And that's something we'll talk about as well. Networking would be the other kind of important aspect, of kind of an orchestrator, because kind of it encompasses so many different aspects, right? I mean, are we looking to build everything within a VNet in the cloud with respect to our kind of cluster IP range or service IP range or bridge IP range, or is there some aspects of on-prem cloud integration we need to solve for? What kind of plugins are we going to use, which would best suit us? Is it going to be like the default KubeNet or the Azure CNI or policies and so on and so forth? So networking is another key component, and obviously, an orchestrator should simplify networking for us as much as possible, right? Service discovery I already talked about, which is about, enabling containers to locate each other, to talk to each other, etc. And then finally, app upgrades, how do you upgrade them seamlessly? So let's now dive into Kubernetes, right? So what exactly is Kubernetes? Rob gave a little bit glimpse of it earlier on when he was talking about deploying on a platform like Kubernetes. So essentially, it's an open source platform for managing your containerized workloads. Basically, anything and everything you run on Kubernetes has to be a container, right? It's definitely become a de facto container orchestration system. Many call it cloud native operating system now. You see a lot of basically companies, right, building on top of Kubernetes and offering value-added services, whether it's kind of monitoring, support, like Prometheus, for example. I think there was a discussion earlier about correlation ID, right? So you can think about Jaeger as kind of a distributed tracing mechanism. There is, Grafana. Obviously, Grafana is visualization tool, can plug into some of the Kubernetes data sources. But it's amazing to see so much work being done in this space on top of this platform, right? And it's also kind of donated to CNCF, so Cloud Native Computing Foundation, which actually is a good thing. Projects which obviously get donated to CNCF would then mandate a certain degree of governance and obviously updates, et cetera, So that's a good thing. So essentially, it automates our deployments, our scaling, operational concerns we talked about with some of the microservices design earlier. And Brendan Burns, I think he spoke yesterday. He obviously is one of the co-creators, and he's for Microsoft now. And this is obviously gaining so much traction, right, within Microsoft, elsewhere in the community as well, right? So let's talk a little bit about AKS next. So you could, and I have done this more than a few times with customers, where we are actually have set up like a Kubernetes on-prem environment, right? Which is challenging, because you set up your control plane, you set up the data plane, which is your worker nodes, you set up the networking infrastructure, so on and so forth, right? Now that is complex. No two ways about it. So you see, more and more vendors who offer Kubernetes in the cloud, right? And our premium offering with respect to that is AKS, which is the Azure Kubernetes Service. It's a fully managed Kubernetes platform, which is hosted in Azure as a PaaS service. And I will talk about later, I think hopefully we'll have some time. I'll talk about, this question comes up all the time. Hey, okay, AKS is great, but tell me, show me like a flow diagram in terms of when should I use AKS, when should I use app services, when should I use maybe, ACI and so on and so forth. So that's obviously a very valuable and a pertinent question. So we'll talk through some of those later on. So when you basically stand up an AKS cluster within Azure, you obviously get obviously a byte curve experience. You get the control plane essentially for free. I believe for a long time we didn't have a SLA for it, like a AKS SLA, but now I think we offer AKS SLA because control plane used to be free, but now I think we have AKS SLA with respect to availability zones. So in Azure, we have the concept of availability zones in terms of making your application or your platform highly available, redundancy aspects. And now if you deploy these AKS clusters within different availability zones, you get a certain degree of SLA, etc. Deeply integrated with Azure DevTools and services. I think Rob made a point earlier about, hey, when I'm building a microservices application, and obviously I will be deploying it on top of containers, I don't want to pull 100 containers, right? From different folks, right, onto my local machine. What I would like to do instead would have to have a mechanics or a mechanism where I can debug these containers remotely, for example, through AKS dev spaces, right, or dev spaces, Visual Studio dev spaces, which is obviously a very unique and a great offering where you can now remotely collaborate with different folks, microservices on AKS, right, using the concept of namespaces. So, each team or each developer can have their own namespace, and, all that gets orchestrated through this a tool which is called as dev spaces. And maybe we'll take some questions towards the end on how does all that get orchestrated within AKS. So let's kind of go through this. I'll talk about demos and stuff in a second. Now let's talk a little bit about Kubernetes building blocks, right? And these kind of are some of the core building blocks of the platform. And I kind of generally follow the 80-20 rule. So 80% of the platform, you learn by learning some of these core building blocks. Obviously, there's tons to Kubernetes in terms of what you can do, and as the previous slide talked about, it being a de facto operating system now, or a de facto orchestrator, you can do a lot more with it, right? Because it's extensible, you can build CRDs on top of it, and that's how you see so many projects kind of being spun out. But in terms of just kind of having like a high-level understanding as a developer also, or as a kind of operator, I think this is good enough, right? So we start obviously with nodes, right? So you have a control plane where you deploy your master. You could have a highly available control plane topology, right? So all the core components go there, and I have a slide coming up next which talks about those core components. And then you have obviously your worker nodes where you're actually running your workloads, right? Linux workloads would run on Linux, machines, and then we also have Windows now generally available inside of AKS. So if you have Windows servers you want to run your workloads on in a containerized manner, obviously you can do that with AKS also now. Docker de facto, obviously, standard for running containers. So Docker obviously is there as a container runtime. kubectl is basically CLI, just like you have a Docker CLI. I'm sure folks here would have played with kubectl before. And then you have those three key kind of, if I can say, objects within the Kubernetes environment. And these are the ones I'll kind of focus on, just in terms of kind of understanding how this whole thing gets orchestrated at an application level, right? So you have pods, you have deployments, and you have services. And then obviously you have volumes and namespaces and, secrets and some of those, if I may, ancillary services. You have obviously cron jobs and config maps, etc. But I think at the core of it is the pod itself, which is a container. So it probably makes sense to understand how a pod operates. And then as we then get into some of the advanced topics like service mesh, it would make sense to see how a service mesh kind of works with a pod, and how does it inject these proxies, etc. So before that, let's talk a little bit about the architecture. So this is like a high-level architecture for the platform itself. So on the left-hand side, you notice you have your control plane. Control plane is your master nodes, right? There's just one node here, but it could be highly available with more than one. And those are the four main components kind of listed there. There's the API server, which is the heart and soul of the system. Basically REST calls go to that API server, and then API server then obviously orchestrates whatever happens on the worker nodes, right? And supplement and the other services or the components which supplement API server or complement are controller manager, which is like a like a control loop running all the time, making sure that the desired state is maintained. So if you said, hey, I want to run Rob's ordering service with 5 replicas and it should be up all the time. That's the job of some of these services, where it's going to make sure using replica sets that if a pod or a container went down for some reason because something happened to that particular rack within that data center, it gets spun up somewhere else, right? And so on and so forth. Then there's obviously the scheduler. I talked about scheduler earlier. Scheduler is obviously for provisioning your containers, on demand. Obviously you can, in different ways. And then etcd is obviously a data store, key value store within the platform. Kind of stores all the operational, transactional, all that kind of data on the Kubernetes environments. And there's a bunch of other services. But these are some of the high-level control plane components. On the right-hand side is interesting. You have obviously these worker nodes, right? And on those worker nodes are the actual pods or your containers or your microservices running, right? And these microservices obviously are going to be, running container, Docker runtime. And there is a component called kubelet. Kubelet is an agent running on the worker nodes, which is basically getting notified by the API server in terms of, hey, do I have anything to deploy? Do I have anything to deploy? Kubelet then basically, sends a command to Docker, and then an actual container, which in this case we call a pod, gets created on those worker nodes. And then there's another component, which is the kube proxy component. So in the latest AKS version of Kubernetes, core DNS. So the job of kube proxy is to basically resolve, these pods for the clients, right? Or for other pods which are basically seeking to talk to them. So back to Rob's if you can visualize Rob's picture, so there's obviously the gateway. Gateway makes call to first the API gateway service. API gateway then kind of aggregates through catalog and all those different services. So those calls obviously have to be resolved, right? Either from a client, which in this case is API gateway, or between the services if we had to make a call to the service. I mean, we talk about best practices in terms of not having to make calls between services, but there will be some cases where we will have to do that. So as I was talking about resolving, right? So kube proxies obviously is then involved in those resolutions. So for example, if you are outside in talking to a pod within your worker node, which is a microservice, it will go obviously through the, if you're doing this in AKS, it would go through the AKS's load balancer, which is obviously layer 4, resolve into a particular worker node, and then within that worker node, it then basically goes through this proxy infrastructure, which is essentially mapping through IP tables to a particular service, and the service, which we'll talk about in a bit here, the Kubernetes service, then resolves to the one of those pods, right? So these pods actually are in the obviously are backing up those Kubernetes services. And I'll give you some obviously examples, demos here in a bit. So this is like a high-level sequence diagram, if you will. So let's say we are gonna run an Nginx image. This kubectl will be outside. It's a client. So that makes a call to API server, on the platform. A pod gets scheduled through the kube scheduler. And then you have these kubelets which are running on the worker nodes. They get notified, and then the kubelets actually notify Docker to run those images. So that's pretty much kind of the high-level, sequence of events which happen. This is rehash here, of the same thing. Master node manages the cluster through control plane. You have kubectl, I had already talked about it. Kube proxy proxies traffic to these pods. Kubelet monitors for any kind of pod activity to happen, and then you have obviously pods, which are a collection of containers. So let's get to pods next. All right, so you can think of pods, excuse me, as a smallest building block in Kubernetes, right? So microservice containers, right? They go hand in hand. So you take one of the microservices like payment, ordering, put that in a container, which is a pod here, right? A smallest building block. But one of the cool things with a pod is you can actually have a collection of co-located containers and volumes. They run within the same execution environment, and they are managed as a single atomic unit. So you, as I said, you never run a container directly. Instead, you run a pod, right? And the cool thing with running inside a pod is the apps within a pod, they share the same IP, they share the port, and they communicate using the native IPC. So think of, two processes or two containers, for example, running within a pod, communicating using local hosts like we do on a machine, right? So there might be use cases where you need that high performance between your kind of main service, application service like a catalog, and let's say a logging service, which is kind of logging some data on behalf of that service. They might as well go as one pod, two containers in one pod. Or, kind of you can maybe stretch it if you have like a caching service, although when you scale a pod, you scale containers within that pod equally. So if you have a Redis cache, for example, with an app running as co-located containers, so when you scale them, they'll scale. But, there might be some scenarios where that makes sense. What we see a lot, obviously, with companies doing, they use the sidecar pattern, especially within service mesh, like Linkerd Istio, where you basically don't use a shared proxy anymore because you want to do like more sophisticated or advanced layer 7 things. I'll get to that when we talk about service mesh. So core orchestration is great, health monitoring, deployment, automation, resiliency, that's all good. But you need, obviously now with, proliferation of so many services out there, you need, more advanced feature capabilities like layer 7, canary deployments, timeouts, circuit breakers. So Rob is going to talk maybe a little bit about that later. So rather than having those within the code now, which is how we've been doing, you take that out and then put that into this configurable infrastructure layer like a service mesh, right? So that you don't have to duplicate code, and all that gets orchestrated through this abstraction. And part of that abstraction obviously is this concept of not a shared proxy, of a co-located proxy. So now you have a co-located proxy which goes with your application container, right? And that helps you do advanced canary deployment, A/B testing, traffic shifting, et cetera, because the traffic now goes directly through that proxy, and now you have an ability to provide configuration data to that proxy, and that configuration data obviously doesn't impact other containers because now you don't use a shared proxy anymore. The other kind of key point with pods is they're immutable, right? So if you, as I said earlier, you can make changes to an existing pod, but that's not supposed to be the practice we follow, right? We make a change to a pod definition, new pod gets created, and the old pods kind of, slowly get terminated, and they can move on. There's another cool concept within Kubernetes, which is the concept of labels and selectors, and I'll show you a quick example of that in a bit here, where most of the resources, other than the labels themselves and namespaces, can be labeled within the environment. So that helps us to do pretty good selection around node selection, service selection, affinity, anti-affinity, as I was talking about earlier. So that's labels and selectors available. And then there's obviously annotations, very similar in nature. Annotations probably more used in terms of, hey, I have this workload. Let me put an annotation saying that this should only go on a Linux, or should go on a Windows machine, for example. So that's where kind of annotations get used more than labels. I talk a little bit about pods. So let's take a step back here before we go to services and deployments. I want to kind of show you a quick example in terms of how this all looks like. So I obviously have AKS running in the cloud, so I have that running right here. So let's go to portal, and hopefully this all works fine. I have a conference AKS, and obviously have a backup conference AKS 1 if this doesn't work. So I won't spend too much time on obviously the creation or provisioning of this cluster. We can talk about that later. This is AKS, fully managed service. I actually have a concept of node pools here. I have a couple of nodes inside a node pool. I can have different node pools. So node pools are nice. A lot of times folks ask, hey, how do I kind of maybe segregate services within my cluster? I know about namespaces, but namespace is logical for most part within the cluster, right? You can do RBAC on top of namespaces, but how can I kind of physically isolate workloads? So node pools is something we have introduced now in AKS. So it uses VM scale sets, right? So you can have different node pools, one kind of with certain characteristics of VMs, size, GPU, etc. Some with, with the Windows-based node pools, Linux-based node pools, so you can do all that cool stuff. There is obviously scaling available, and we'll talk maybe later on some of this. But I'm using this just to show you some of the foundational aspects of Kubernetes right now. So what do I have here? I have a very simple pod, which is, let's go to labs here. I have a simple pod example. And I'm kind of assuming a few things here, right? The knowledge, right? So this is like a manifest, a YAML file for building a pod. The kind is a class of an object. So kind could be a pod, which is your container. Kind could be a service. Kind could be a deployment, so on and so forth, right? And here we're saying, hey, go ahead and deploy this container Nginx as a spot. So in this case, we're just kind of expecting to deploy just one container on this particular port. And then later on, once I go through this, I will be definitely talking about Rob's demo today, that microservice-based solution. So we have that actually orchestrating on top of AKS. So that's kind of more of a real-world type of example, but this is just to kind of bring up folks to speed who probably haven't seen this before, right? So now I'm going to do a kubectl apply. So apply base. So there's create and apply commands. Apply is good because you can it's declarative versus imperative. So you can keep applying, and then the only things we change would get reflected. So simple pod.yaml. Before that, just to show you that I have obviously in the default namespace no resources. So we do kubectl apply simple pod.yaml. Let's create it. I can do get pods. Perfect. Now just to make sure it works, let's do a port forward on this guy. Because it's running inside a cluster on an internal IP address, which I have no access to. So I'm just going to use some port forwarding trick here. So let's do 89P280. Forward traffic. Go to my, hopefully, with the streaming, I don't break anything, right? Concerned, so it was 8090 localhost. All right, so that's our pod running on our obviously Kubernetes environment. So we understand that that is pretty straightforward, right? Come out. Okay, perfect. But the problem is, let's say somebody comes along and says, so let's say get pods. Yeah, I don't like this pod, right? So let's go and delete that guy, right? So let's say it's deleted. So I go look for pods. Yeah, I don't have a pod. Perfect. So how do we kind of maintain the desired state, right? So that takes me, obviously, in the interest of time, I'm kind of fast forwarding here to the next piece, which is deployment objects. Obviously, there is replica sets, which is the backbone of how deployment objects work, but I'll just explain it through deployment objects. So that takes me to the next aspect, which is, how do we deploy these services or microservices on top of the Kubernetes environment, right? So we can run standalone pods, right? But then how do we get desired state, et cetera, et cetera. So better alternative is obviously to use deployment objects. So that's, again, a Kubernetes object that manages, releases, updates, scaling, aspects of the deployment. You can do rollouts, you can do rollbacks, and essentially these deployment objects, they internally use the replica sets, right? So you basically, set up certain number of replicas, and obviously if you say one, then there's always a redundant replica somewhere so that you get the desired state. But this is obviously a better way to manage your microservices deployment using the deployment objects. So quickly, to kind of keep it more demo focused, my presentation. So let's see what an object looks like. So here's the kind deployment. We are doing obviously the same thing again. We are spinning up a container, as you can see here, which is again the same Nginx container. And we're saying, hey, give me one replica for now. And we are obviously setting up some labels. And you'll get the significance of labels shortly when I kind of show you a Kubernetes service. But here we're just saying, hey, let's set up some label dev for kind of a key target, right? And could be basically anything, right? So make it more relevant. Let's say .NET Conf. Let's say .NET Conf. So that's the label key. That's the value. Anywhere else? Nowhere. And we are basically, I have just one node pool Linux. So I didn't need to use a node selector. But if I had like multiple node pools, with different configurations, and I'll be better served doing this. Okay, so this looks all good. Label target. Okay, so let's go ahead and run this. So we'll do apply. All right, so now we have a deployment created. And I obviously show how all this comes together. So this session is not just Kubernetes. This is also to show you how all this kind of comes together with what Rob has been talking since morning, right? So we want to obviously tackle some of those core aspects, right? More sophisticated aspects. But this is just to kind of level set in terms of what all this means. So this is a deployment, and I can obviously describe the deployment, which I won't do it, but so there's a describe command. But we understand this is a Kubernetes deployment. There's one pod running, 101, because that's the replica we saw set up with. I can do a kubectl get pods. There we go. So we have a pod running, and now, and I could do port forward and all that, jazz, and I would definitely be able to get to that Nginx endpoint. But what I'm interested in right now is to basically come along, me or Rob, somebody comes along, doesn't like this pod, and says, hey, let's delete this pod. And now if I do get pods, what do you expect? You obviously expect the deployment to do its job, which is to maintain the desired state. So here's JW7WQ, unique pod, and then there's this different pod. So that pod, boom, it's gone. It's a mutable infrastructure, so it's deleted, but a new pod got quickly spun up. And obviously here there's just replicas set up as one. You could have as many replicas as you look for, right? Looking to have. So that's the second major kind of component. So as I said, 80-20 rule. So we looked at pods, the basic building block. We looked at deployments. So obviously your Kubernetes deployments in your organization would be obviously based off this deployment object for most part. And then how you obviously carry it out. I mean, you have different options. You can use infrastructure as code and ARM. You can use Ansible. You can use Terraform. Obviously companies do it differently, right, in terms of how they orchestrate that automation, that pipeline, et cetera, et cetera. So now let's look at the final piece here, which is in this context of a service. So it's all nice, cool and dandy. I got pod running, but it's still running internally, right? It's still running on a particular IP address. In this case, I could basically find that. I could do, I think so, I could. If I do kubectl get pods, give me an IP address. So it's running on an internal 10.244.2.40. That's obviously my configuration which has been used to create the cluster. This would be the cluster/pod IP range, right? And then it picks up an IP address and randomly assigns that. And there's no way this IP address can be accessed from outside, right? Unless obviously you use Azure CNI and then you're within the network and you have access to that configuration. But typically if you're running in the cloud and then you're running it as a truly PaaS service, you need a better mechanism to be able to access these kind of pods, right? So that takes us to the next segment of this piece, which is a Kubernetes service. So Kubernetes service is also like the deployment objects and the pod object. It's an object within the Kubernetes ecosystem, and this object actually is responsible for helping us communicate to these pods, right? And Rob mentioned about microservices combination. We saw those beautiful looking pictures in terms of catalog, basket. So those are all now going to be running inside these containers, right? So how do they discover each other, right? If they discover based on IP address, that's going to change the next moment, and then you basically don't have a service up and running, right? So we rely on these Kubernetes service objects, and these service objects basically abstract and they logically define an endpoint for us. So you can think of these as VIPs, right? Like virtual IP addresses. So you have obviously these pods running for a particular service because I ended up scaling that service to multiple pods, and now I have the service IP address, right, which is like a VIP, virtual IP address, which then gets backed up by those different IP addresses, right, which are basically your pod IP addresses. So that's essentially the kind of the essence of what a service object is. And typically you have these service objects which expose these Kubernetes services in a variety of ways, right? So you obviously have a default configuration which is the cluster IP, where you get that cluster IP, a default single IP internal to the cluster to present the pods, which is great. Then you get a node port. Node port is pretty neat as well, where you are able to reserve a specific port on a node, right? So let's say you have a kind of an on-prem topology, right? And you are kind of in the sector where you basically are deploying. Let's say you're an ISV deploying on behalf of your customers, or they end up doing it within like a one node configuration, right? Let's say they're in oil and gas, and they don't have a data center where they can run these load balancers, F5s, whatever, autoscalers, etc. And then you basically deploy. You want to use Kubernetes, which gives you scale, and you want to deploy an application. But how do you surface that application internally, right? If it's running within that machine, without maybe having an F5 or some load balancer, right? Integrated. So you need a node port. You can say, hey, let me take this worker node, make that worker node's IP address available on this particular port, which I've reserved through node ports, right? So that's your one approach. And then kind of the commonly used approach for, let's say, web services and APIs, which obviously get, exposed externally, within your organization through an internal load balancer, ILB, or you want to expose them outside to the World Wide Web. You could use the load balancer of the provider, like Azure has Azure Load Balancer. You get this particular scheme or a type, which is called as the load balancer type. And that kind of follows that the communication channel, which I kind of explained earlier. You're outside, you go in through the Azure Load Balancer, which is the layer 4 load balancer, into the node. At the node level, you get resolved through kind of core DNS into an appropriate pod, right? And obviously, kubelet, core DNS or kube proxy, they obviously are always in sync with the control plane, because your services can be rebalanced as well, right? Service is logical, but still, the pods can be rebalanced. So you may not have a pod available on the node on which you got resolved for some reason. So you'll have to bounce back to a different node, and all that orchestration is taken care for you, right? So which is neat. So let's go back and use the same example, and now try to expose this Nginx externally, right? So let's go back and let me show you the VS Code for that. So here's the service, pretty straightforward, and we're saying type is load balancer. And then one of the key things here, when I'm presenting this, obviously for folks who haven't done this before, how do they kind of visualize a deployment which is running pods to a service in terms of connect? How do they connect to each other, right? That's a basic question. And that's through this concept of labels and selectors. So if you notice in our RGDP file, we said the label is this guy. So we're going to go to our service, and we're going to now select based on that label, right? So what that means now, when this service is running, it's going to get hooked up to those pods, because when you basically deploy the pods with those labels, they obviously get set up like that. So now we have a target at conf, and now I can actually go ahead and say kubectl apply, because we still have, let's see if we have still, so far so good with my network performance, chain performance. So let's go back and say apply service, and this is all running in the default namespace, as you see. So now we have a service running, so we can say deployments, pods, or pod, or SVC. So I have this deployment going on. I have obviously a pod running as a result of that, and now I have obviously a service running as well, and that service is pending an external IP address, which should not take much time here. It's up. So this uses obviously the layer 4 ALB, Azure Load Balancer, opens up an IP address, and now that IP address, as I said, gets orchestrated through that particular design. So let's copy that guy. And let's go ahead and run this. Okay, perfect. So that's our Nginx right there. All right. So that is the first piece of the puzzle here. Any questions, Jeff, Rob? You may have seen come along.
Jeff, any questions for Manu? there have been a number of questions, and the chat room's actually been doing a real good job of helping each other. There's been a really good community back and forth that we're seeing. Folks asking questions about, how do I get started with containers? What is a container? How do I compare a container to something? And we've seen some real good comments and support there. Code with Sean's been a big help. Thank you so much. Helping out there, answering some of the questions for folks that are getting started. There's a bit of a discussion about CLI for deployment and configuration of Kubernetes versus using graphical interface. So that's always a good discussion to have about, well, what feels better. So lots of things that.
Okay, so no particular question.
No, I don't see.
Going on,
yeah,
cool.
I think we can continue.
Okay, so let's continue. Perfect. So what I want to do next, if I can, let's go ahead and show you a dashboard. And using the dashboard, I'll talk about a few other aspects like volumes and secrets, etc. So let's see if I can open up an SSH. So AZAKS browse. By the way, just kind of like I know these questions have been answered on the channel already, but the best place would be if you're looking to do AKS and learn Docker, alongside with it, or containers. You can go to Microsoft documentation, search for AKS Microsoft. Amazing documentation. It's you can try those out yourself through obviously our cloud. A console we have right within the portal, etc. So it's pretty neat. So let me go ahead and create a tunnel. So AZAKS browse. My resource group is conf.rg, and this is conf.aks. Give it a second here. Come on. Okay, so let me open. I think I should be able to do this in Firefox. Just want to show you the dashboard for Kubernetes, just kind of a way for you to explore different capabilities and stuff like that. So let's kind of do 127. This guy here asked me. Close that. Let's do 127. Ask me for a token. So this is the dashboard. It basically needs a token, and I'm providing it the token, and I'm right inside the dashboard. So here are all the pods, or just one pod so far, which is what we deployed. And this pod, if you notice, is just running one container. And in my next segment, I'm going to go deep into service mesh. I'm going to go into layer 7 things with Istio, with Linkerd, and show you some deployments as well. So in that case, you would have more than one container running because, as I said earlier, there would be a proxy container running alongside your application container. But here's the container. You can look at some information, resource usage, etc., etc. So we talked about that. We talked about deployments also, right? So this is our deployment. I could very well go ahead and say, scale this deployment, obviously in an automated fashion, preferably, and not through the UI, so on and so forth. Here are the services. We have an ng service running, which is the service we created for Nginx. So quickly, I want to touch base on a few things here. So one is config maps. So let's say you have these pods running, and these pods, basically are your business functions running, right, on the AKS platform. So how do you provide configuration to these pods, right? So you would typically provide configuration to these pods using what we call as environment variables, right? And these environment variables are, basically, then stored within config maps, right? So you can use maps to stand up these environment variables, simple value or file. Next, right? And what you can feedback, you can put routes, so on and so forth. So that obviously is a net, right? So that can go right within config map. or a simple, text file with some basic secrets. So secrets is the other thing I mentioned earlier. So anytime you have any sort of data, obviously it's preferable to put that within Key Vault because you get that data properly encrypted. Furthermore, I do have a demo for that, but I don't think we'll have time to go through it. But maybe we'll post it on kind of even a better flavor to doing identity, right? And manage identity obviously can be implemented ways, but the way right now is mostly implemented is through Pod Identity Project, which is an open source project, and it basically uses Azure orchestrates that for you. So now you are not in a business of storing sensitive data in your pods, etc. Right? So because images can be distributed, and you then get into the situation of kind of vulnerability, right, or with the sensitive data. Persistent volume claims. One thing we yet is about these containers. They're ephemeral, right? So they come and go, and you cannot rely on these containers for any kind of long-term. So how do you persist data? And that's obviously so core. We do. It's at the end of the day, it's all about data, right? Data. So how does that work? Obviously, you have within that context, you also have a concept of stateless and stateful apps. So even within stateless apps, right? I mean, you have data, right? And, let's say your application generating app inside, obviously, push into that out offering what it's pre-aggregated pre-index. You're using like a lot of OAuth within your ecosystem. You're using Prometheus, you're using Jaeger, you're using all those tools, Kali, for example. So that data which gets generated, which is obviously getting generated through a pod, how does that get stored for a long-term persistence? So that's where you use this concept of persistent volumes, right? So within AKS, we have obviously different plugins available. You can use for storage classes. You can use Azure Disks. You can use Azure Files. You can use, I believe, NetApp, and so on and so forth. So you have those different storage classes available. I just jump over classes quickly if I can show you. So Azure Files, as I mentioned, we have Azure Disks here, right? And then we have an Azure File Premium now, which probably got released sometime back. So you use these storage classes, and obviously you're not just relying on these. You can do more than this as well. I think the documentation on our Microsoft website is more current on this. So you have the storage classes, which then basically you bound your volumes to those storage classes, and then as a pod, you don't want to kind of tightly couple a volume or tightly couple a storage class volume to a pod. So what you do kind of is this decoupling where you say, hey, let's give a persistent volume claim to a pod. So a pod, raises its hand, say, I need a claim with so much of space or with such and such right. I'm just a read-only pod. I'm just going to go to that persistent volume storage class, read some stuff, right? Or there could be pods which may be obviously read is idempotent, read as many times, write once, could be read as many times, write multiple times, right? And then you can have multiple pods, obviously, be able to do simultaneous, read writes. Obviously, with a certain storage class, there are some limitations there, but that's the basic idea, right? I mean, you have these pods, they need to persist data, and the way to persist data is through volume mapping. And within a platform like Kubernetes on AKS, you basically are served pretty well because you have all those abstractions available to you, right, through these persistent volume claims. We'll talk about ingress in a bit. I'll show you some service mesh stuff, and we'll go through that, but just kind of high-level stuff. Here, namespaces, namespaces, obviously, simple concept. I mean, a logical construct, where you kind of divvy up your workloads into those namespaces, but folks find it very useful because now if they're using their clusters for dev tests, they can logically isolate dev test workloads within those different namespaces. And if you were not having a namespace which is different than the default namespace, then you would basically be subject to the uniqueness constraint. So you cannot say Rob's container and then deploy one more with the same name. Now, if you have Rob's namespace and Monu's namespace, you can have containers with the same name, and that's just an example, right? And then you can also, in Azure, we have obviously a very robust RBAC through Active Directory integration, And Kubernetes also offers very, very sophisticated RBAC internally through cluster binding, or it can have be a namespace binding, right, for a particular role. So you can do all that kind of nice, slice and dice of workloads within your clusters.
I get a massage tonight. So.
All right. So what we'll do next is we will go ahead and show you our microservices application. Let's go there first. And I'm not going to open code. I think Rob did a great job. I mean, he showed most of the code. Maybe I may need to show it for the Docker file. So I'm hesitant to open too many windows right now. So let me see. Can I find my Docker file here somewhere? Okay, we'll take a chance. It's okay. Okay, putting up. Jeff, am I sounding okay, or is the network choppy?
Things are a lot better now.
Okay, I'm on Wi-Fi. I could connect to Ethernet as well. Let me know. Okay, so
while that's coming up, and we get set up there was a question that came in, asking if you can ingress using the service name instead of a label.
You can ingress using a service name instead. Yes, yeah. Question more like for a headless service, for example.
Yeah, I think so.
Yeah. You could create headless services. Yep.
Okay, there you go.
Okay, so let me just open up this project, and I just wanted to show just one thing here. Hopefully, this doesn't crash me. Okay, so we have done. So we have taken obviously all these services. So we have gateway, we have basket, we have a bunch of services. We have basically containerized the workloads, right? And I think Rob mentioned it earlier. This is like a training project, so I'm sure there'll be a comment about, hey, why isn't there a multi-stage Docker file, right? So obviously, when you deploy this in production or even in test, you got to have maybe a multi-stage Docker file which publishes the artifacts and doesn't push everything into the container image. But nevertheless, we have this Docker file which we used. We are using ASP.NET 3.1 as a runtime, and we are exposing our API gateway, API DLL, through the entry point, and then obviously we do that for each and every service. And then these containers are exposed on port 80, all of them. We don't have port issues or port conflicts on the cluster because they're running on different IP addresses on the pods. So, and then we abstract that through Kubernetes Service, so it's all good. And expose here is mostly basically that's the port which it's listed. Another thing, to kind of remember again is the pods, right? The pods basically, if you have multiple processes running in, and this question comes up all the time, hey, can I have multiple applications running in the pod? Because, I want to do them, even though, it may not be always the best pattern. Maybe in some situations, mandate you to do that for whatever reason. They still, keep in mind, they still run on the same IP address. So one way to do that would be to then have one of the containers run on 80 and the other container run on 8080. So that way, you'll have to obviously, kind of divvy up those services. So, so here's a Docker file for one of the services, and that's all there is pretty much to it. And
hey, Manu.
And I am going to close this
Manu.
to get into trouble here.
Can you zoom in
screen share?
Manu, can you
go ahead, Jeff?
Yeah, can you zoom in a little bit there? The font size is really small. Yes.
Oh, okay. Okay. I'll do that. Just 1 second. let me do this here. Let's just close this guy here quickly. Let it sit your window. Just give me 1 second here. Okay, so let's go here. I'll just open the Docker file. Just show that again. Yeah, it's taking time to come up. Why don't I come back to the Docker file, Jeff, in a second. Let me move on. I'll come back to Docker file. Still hear me, Jeff, okay?
Yep, that's fine. Yeah, we can return to looking at that in a little bit.
Perfect. So why don't we now next step, which is basically take our Microservice application, which Rob showed you guys in the morning, and deploy it on top of our AKS environment. How do we do that? So we would create, as I showed you earlier, we would create obviously deployment objects and service objects, right? And we have deployment objects for each of the different services we have. So we have one for catalog. You notice here, this is the environment variables, right? Which we have, we could also read that from, basically they have here to show you different options you have. We could very well have sourced these from, Kubernetes secrets, or we could have managed identity, or we could have used key vault. So we're very different. Obviously, you don't want to, put them clear text like that. It definitely come through like a service which is built to store sensitive data, right? So we have these different services, different services being created using deployment objects, right? So if you notice here, all these are different images, right, for individual objects. And notice this cool thing here. This is when Rob was talking about the API gateway, talking to these different services and kind of acting as a gateway as well as like an aggregator of sorts. You could also have an optionally an aggregator service sitting in between the gateway and your different application services. But notice how it is able to, this is using the power of Kubernetes platform and the networking available, where now we can access these different pods using, like a DNS. HTTP catalog, HTTP basket, HTTP ordering doesn't exist outside of the cluster, but within the cluster, it is like a first class, domain name, and it gets resolved using obviously Kubernetes services, kubeproxy, core DNS, and whatever we discussed earlier. So, so these are all the different deployments available for all those different services we have. So notice how for ordering we have these different environment variables for the Cosmos DB endpoint, the service bus connection string, which Rob talked about in his event bus discussion, where you communicate these different events as obviously commands, and then you have command handlers. You have events, and then you have event handlers, which basically handle that event on the subscriber side, and so on and so forth. So along with these deployments, we have the concept of services. So now we have the service for catalog, we have a service for API gateway, we have service for basket, and so on and so forth. And the one thing which ties these is obviously, in this case, the labels and selectors, right? So we have labeled these deployments appropriately, and on the service side, we select based on those labels. So at this point, we are pretty much ready to run the app. So I'm going to basically open up a new CMD. And let's go and let's go to dir. Let's do kubectl y deployment v2.yaml. And as you see here, all these different services have been deployed. So if I do kubectl, let me just get pod and svc. Perfect. So IP addresses come along for the UI, and the UI basically has been set up as a load balancer because I want to kind of expose that outside. And see, all these different pods are running. Just one pod right now, running one container. Pod running for a service, running one container, and these are different services. So let's go ahead and copy that and just go here and make sure that that thing is up and running. Your music store app. I can go ahead and whatever Rob was showing earlier, so kind of same app, same experience, submit an order, looks good, so on and so forth. So that's nice, right? Now let's kind of talk a little bit about, Jeff, do we need a break right now? Maybe a 5-10 minute break before I move to service mesh?
You know what? That's not a bad idea.
Yeah, for almost an hour and 15.
Yeah, let's take a 10-minute. We'll come right back in at about 5 of the top of the hour.
Sounds good. Perfect.
All right, friends.
Thank you.
In just a minute.